House Massachusetts. I recognize most of you, you're regulars here at this point, but I do see some new faces as well. So I want to say welcome. We do these meetings every month on the second Tuesday of the month. We've been doing them here remotely for the last couple of years, year and a half or so. But we were just talking earlier today with our board of directors about returning to doing some in-person meetings here this summer. So we'll see. We're testing the waters if that's something we feel comfortable with. If anybody here has any feedback on that, feel free to reach out. You can also, type stuff in the chat room today to kind of let us know how you feel about it. But we're kind of thinking about, it'd be nice to see everybody in person again. So we kind of like to get everyone back together. So we're thinking about doing that. But anyway, tonight, our March meeting here, we're going to be talking about the Ice House condominiums with Lucas from RTH. I have a couple updates I'm going to go over first. And then I'll just hand things over to him and have the presentation, take it away. During the presentation, if you guys have questions, feel free to use the chat room to, type out your questions or just discuss different topics. At the end of today's presentation, we'll, save the rest of the time for open discussion. So at that point, we can read out your questions, we can unmute you, whatever you feel comfortable with, and we can have a discussion and Q&A about the presentation itself. So I just want to go over, like I said, a few things. We've actually been talking about this for a good year or so about kind of updating the stretch code here in Massachusetts to be a net zero stretch code. The climate bill that was passed last year mandated that the DOER take this on and actually write a net zero stretch code into law, and they have released their proposal for it, what they call their straw proposal. This proposal features an updated base code, an updated stretch code, and then a third new opt-in specialized code. And this is what the net zero stretch code is this specialized opt-in code. There's a lot of information about it. You can find out details on our website. So quick resource, phmass.org/policy. On the bottom of the screen brings you there. The link right above that on the screen is to the mass.gov's kind of site where they have all the info. The key to keep in mind about this is they've had a few hearings on this. The last one just ended today, actually, but they've extended the comment period. It was supposed to end today, and they extended it through the 18th. So through 5 p.m. on the 18th, you can submit written comments. So on here, you see the email stretch code at mass.gov where you can submit comments to. Go onto our website. We also have a link to this as well as all the documents we've written about this in terms of our position on it. So you can check that out all there on that policy site. You can also sign on to a letter that our partner MCAN has put together. So that link here is on the screen. That link is also on our website. So you can go there, sign on to that letter to kind of show your support collectively. You can also make your own comments by emailing them directly here. And again, they'll take those comments through the 18th. And if you're curious about our recommendations, we've talked a lot about it in the past, but you can see that on our website where kind of get a sense of where we're coming from on this, what we're commenting on. This is just a slide from their straw proposal, a draft that they released, just showing you that the specialized opt-in code does feature passive house in a lot of places, but in a lot of ways it doesn't go as far as we want. So you can see some of those comments on our policy site. Something else that just came out today that some of you may have received in your email box, just like I did, is that Mass Save launches their 1 to 4 unit incentive program. So this is something we've also been talking about for a while that they were working on. We're really excited to see it actually here now. So those of you who have been here or regulars at our meetings know that there's a passive house incentive program from Mass Save for a 5 unit or larger residential building. So that's been in place now for about 3 years. Very, very successful, driver of passive house projects, in the larger multifamily sense. Now this program is geared toward 1 to 4 unit buildings, and it doesn't require passive house necessarily. What it does is requires energy performance over a baseline or a certain HERS score. So you can see the details there, but we're just kind of learning about this as well and kind of getting up to speed on it. They don't yet have this on their website that I could find to point you to, so it's only in that email. But hopefully they're going to get some stuff up soon, and we'll make those resources available as we get access to them as well. But so far, this is the info that they put out on it. And something we do know is while this is kind of targeted at new buildings, retrofits can apply for these same incentives. So that's sort of a really good thing to keep in mind, especially with us, as we're going to prioritizing retrofitting our existing buildings to be either passive house or to be deep energy retrofits. So this program can work to incentivize those as well. So we'll learn more about this. We'll have more to say about this next month and through emails and on our website to find out more about it. But this is sort of an exciting development here right now. So those are the things that I wanted to mention. Again, go to phmass.org/policy. I'll put some links in the chat room throughout today's session as well. And then there was a question here in the room to share some slides and some info, so I'll work on doing that as well. Oh, and Luke McNeely from ICF, who is the vendor for MassSave, just mentioned in the chat that he's open to asking some questions. So if you guys have questions about those, feel free to type them into the chat room here today, and Luke can get to some of those questions as well. But with that, I'm going to stop sharing my screen, and I'm going to welcome our featured speaker here today, Lucas from RDH Building Consulting. Luke, oh, sorry, I just covered my screen here. But Luke is going to talk today about Ice House Condominiums, a retrofit project that they've been working on as a consultant out in Provincetown. So Lucas, you can share your screen and take it away.
Thanks, Aaron. Thanks everybody for having me. Just some housekeeping notes. I can't necessarily monitor the chat during the presentation, but Andrew is going to be hanging out in the wings, and feel free to interrupt me. I tried to keep this. I think there's going to be a lot of discussion that'll come from the presentation, and at least that's the goal of it in general. So I didn't try to fill up the full hour block because I think we'll have some questions, and also I think this type of thing is better as a group discussion. So without further ado, I'm Luke Nargang with RDH. I've been here operating in the Boston office, or out of our Boston office, since its inception about 4.5 years ago. Prior to that, I was located in our Portland, Oregon office for about 4 years. And here I am in Massachusetts. And I used to be a semi-regular at the PHMass meetings. Then COVID happened. Then we hired Andrew, and now he is the RDH designee, if you will. So without further ado, here we go. So here's our general disclaimer page. If you would like to read it, I can send it to you, but we're just going to kind of flip past this. So a little bit about RDH, shameless plug here, because we've got to. Let me just move this out of the way. So RDH has been making buildings better for 20+ years, almost 25 now. Actually, I think this is the 25th year for us as a company. We're about 300 people globally, and when I say globally, that's a gross exaggeration. We're actually just located in North America, so my apologies. So we are, to date, we have about 7 million square feet of high performance buildings under our belt, and that is mostly passive house and net zero. Our Vancouver market, which I'm sure you're all very familiar with, and how far along they are in their passive house journey, that's where most of that is. We have expertise in new construction and existing buildings. I mainly operate on the new construction side of things, and every once in a while I will dip my toe in the existing building side, and that's what we are here to talk about today. So a little bit of background about the Ice House. So the Ice House is located in Provincetown, Massachusetts. For those of you who have wandered the streets of Provincetown, you may or may not have come across this building on Commercial Street. It is right smack dab on the ocean. It was constructed in 1907. It was actually one of the first cast-in-place concrete buildings located on the Cape. It was originally built as a cold storage facility to support the local fishing industry. There used to be a very large wharf that was off the back of it, where the ships would come in and they'd pack it full of ice. I think at one point in the building's history, it also served as cranberry storage. So that's a fun fact for everybody. And so then it's changed hands a bunch of times throughout its history, but the final time that it changed hands was in the 1980s, when it was then purchased, and after a long drawn out legal battle, they gained approval to build or convert it to 23 condo units. For some additional context, this building is located in the Historic District Commission, which is something, or sorry, in the Historic District of Provincetown, which is, as those of you who have worked in historic districts in the past, it can definitely limit your ability to get creative and also take the easy route in improving the performance and repairing a building or making any sort of wholesale changes that alter the appearance of it. Further to that, much to our surprise when we got involved in the project, is the building is already 100% electrified. So as you kind of will see as we get through this discussion, this project never started out as, hey, we're gonna go look at this building and do a deep energy retrofit of it or try and make it a passive house. Where it started out was we got a call that said, hey, we have a bunch of leaks and a bunch of issues with our building. Can you come take a look at it? And then as we got deeper into it, there were some opportunities that were afforded to us. You know, the fact the building was electrified, some of the issues that we found to kind of really take a stab at moving this building in the direction of a high performance building, while also satisfying the mandate that was given to us by the ownership group. So here's the beachside view of it. As I mentioned, it's about 40 feet from the water. So, you know, you're looking right out at the ocean here. So it's a pretty spectacular view, but also it does get beat pretty badly with storms, which is another, you know, consideration that this particular client had for us. You know, it was really refreshing to come across a group of homeowners that were so acutely aware of how things are changing, especially the long-term owners out there, getting to see those storms that hit the building being stronger, getting to see the storm surges get higher. There's a lot of discussion about what to do with the building enclosure and the assembly, mainly at the ground floor level, since it is actively in a floodplain. Okay. So as I said, you know, I came here in Boston in 2018, and then I think it was November of 2018, we were engaged by a structural engineer locally on the Cape to come take a look at this particular building. The main objectives of our condition assessment, which was focused in on just the enclosure, was to understand the existing buildings or the existing assemblies, look at the performance of those assemblies when it comes to thermal performance, but just also how's it managing water, how's it managing air, you know, the general building science stuff that we dig into. Further to that, we want to understand the occupant observations that they have with respect to the enclosure. You know, are they seeing condensation? Do they get active leaks anywhere? And then the result of that is to compile all of that data and really provide some high level recommendations to them about what they can do from a deferred maintenance standpoint, or from a or from a longer term, larger project, larger renewal situation. And one of the unique things about this project, you know, normally when we do a condition assessment, when we do an occupant questionnaire to the people residing in the building, you know, the condensation question is something that a lot of people are able to answer quite readily, because, you know, anytime you have a double pane window that's not thermally broken in a very cold winter's day, especially in the morning, you're going to see that condensation. But the occupancy in this building, given the fact that it's on the Cape, I think there's only about 3 year-round occupants. So really nobody had any idea of what happened to their unit during the winter. They have a local project or local property management company that would come and check on the building every once in a while, but there were a lot of unknowns, but which actually made this portion of the project a lot harder, because we could only kind of infer from what we saw visually and then the few openings that we did. So the general scope of this, we always approach things with a document review, an occupant survey, then we do interior and exterior walkthroughs. We actually did IR drone scan on this particular project. And then we did some roof window and interior openings. And in general, our scope included looking at the interior operating conditions, internal relative humidities, temperatures, that sort of thing. Looking at the walls, windows, sliding glass doors, in-swing doors, skylights, smoke vents, balconies, basically everything on the exterior enclosure. What the takeaways were is that we have ongoing water intrusion in the building, whether it's noticed by the occupants or not. A lot of people have occupant comfort issues. It's very drafty. They're concrete floors that are unfinished for the most part, exposed. If I go to the next slide, you'll see that, we've got exposed concrete elements, which are the superstructure. So these are just exposed spandrel beams. So we've got a lot of cold spots in this building. And, even when we were there in the wintertime, you could definitely feel the drafts. Further to that, the west roof of the west roof of the building. This is the west building here. The roof is it is near the end of its service life. It's been patched multiple times. There's actually an interesting phenomenon that happens on the Cape where seagulls will carry seashells and fly up over buildings and drop the seashells onto the roof, trying to hit something hard to break it open and eat whatever is inside of it. Somebody who had never lived this close to the Atlantic Ocean or designed it was I thought the maintenance guy was pulling one over on me. I thought for sure he was lying, but apparently it's a thing. The other thing, let's see, what else do we have? In general, so the wall assemblies here are interesting. It's a infill wall that is a steel stud, 3.5-inch steel stud wall. It's got gyp on either side. Early 1980s Tyvek, which is a collector's item. And then it has a drainage gap and a 3-inch wide brick masonry veneer, which is then parge coated over with stucco to seal up all possibilities for it to drain, and then coated with an elastomeric coating. The other interesting thing we found here, the window system. So the windows are a Pella wood window with steel cladding, inset into an abandoned metal frame with a flange that was behind the brick veneer. So rather than when this window replacement project happened in the early 2000s, rather than going through the trouble of demoing the masonry, they just cut the frame and installed a wood window inside of the actual frame. So it was like an inception window. It was a window within a window, and as a result, it all sucked. And so we ended up with what looks like properly or improperly sized windows, but in fact, this is an AZEK infill around an abandoned frame, and all of this is face sealed. So the entire assembly of this building relies on a perfect exterior coating to minimize water intrusion. So in general, our goal was, or our final recommendations for everybody was that we wanted to try and improve the water management. So our long-term conceptual rehab repairs were, let's replace the roof. The roof's in poor shape. Let's put that on a 0 to 3 timeline. Then we went with, we talked about replacing the existing windows. And that involves actually removing both windows, the old metal frame and the newer wood windows. And we put that out at a 5 to 10 year timeline, knowing that, that's a pretty expensive process. And then at the end of the day, we also recommended doing an air seal and a water seal, or installing, an air and water barrier over top of the existing facade. And then going with kind of the energy sprung approach of either a drained eaves system on the exterior or a cement board stucco. And then we also provided them with some additional recommendations for what they could do in the interim in terms of trying to just manage some of the water that's on this building. From the previous slide, all of these infill walls are inset. So we get water that comes down here. There's no drip flashing here. It rolls back onto the face. It rolls down. It sits on this edge, comes around, rolls back. And all of these gaps are cracked and open. So you get water that's able to kind of slide back in at all of these interfaces. So we recommended, in the interim, let's add some drip flashings. Let's reseal over top of the stucco. Let's look at the roof drainage, because right now the roof was drained with through 2 scuppers that were 3 inches around, and we had a large amount of ponding water. Replace exterior sealants, and then create just some general maintenance requirements, like on the terrace back here. So wood terrace over an EPDM membrane, and there's no way to actually access the drains here. So we had large amounts of standing water underneath this thing because the drains hadn't been cleaned out in a couple of years. And then, some additional low-hanging fruit, like addressing your traffic coatings, looking into some further issues that we were unable to get to during our initial condition assessment, for like the leaky skylight, and just continue in the interim before you replace your roof, to react to ongoing water intrusion issues in a reactive maintenance perspective. So, we made this presentation to the owners, walked them through the state of their building, and much to our surprise, they actually engaged us to do a holistic repair of the building. A lot of the time, it's a whole building rehabilitation is something that comes with a pretty large price tag, but given the severity or the chronic illnesses, if you will, of this building, the ownership group elected to actually move forward and try and tackle this thing in a holistic approach. Do we have any questions, Andrew, at this time, as I take a drink of my coffee?
None in the chat so far, Luke.
Okay. So the scope of our rehabilitation project, typically what we'll do is, we'll go in with an additional level of investigation, which is us opening up more areas of the building to try and understand the underlying construction so that we can actually fully diagnose the issues and then design out from there. The next phase is the design and the analysis, and then implementation. So this particular project, we are, Andrew and I are actively working on it. We're actually just completing the design and hoping to go out to bid here in the next couple months. So, this is a story that is only half told. So maybe we'll come back in a few months, and by months I mean few years, and give everybody the rundown of how this thing ended up, and what lessons we also learned during construction of this rehabilitation project. So the goals that were given to us by the owners were to correct the water intrusion and occupant comfort issues, and that the new enclosure needed to be durable and low maintenance. Something that they have constant issues with on the Cape is just finding people to come out and actually just do regular maintenance out there. There's only a few construction firms, or you've got your mix of handymans and small mom and pop contractors that aren't necessarily either equipped to do the work, that some of this maintenance work on a larger building like this. So getting people to come out and work on a 5-story cast in place concrete building is difficult. So we did some additional investigation, which was basically involved 12 exterior openings. And that was kind of what we had planned originally for the extent of the exterior openings. And based on what we actually found on the exterior openings, we needed to do 10 additional interior openings to really get an understanding of what was going on, and I'll touch on that on the next slide here. So what we found in the walls, so we actually found that the existing steel stud framing behind the masonry system was heavily corroded with significant section loss in several locations, and if unaddressed, it could lead to a life safety issue, which, right off the bat, that was like, oh, there goes that initial plan of how we wanted to address this. It was mainly concentrated around the windows, which, we kind of suspected that the windows were leaking, and, we didn't really get a lot of reports of water intrusion during our investigation or during our occupant survey. And it was just, we were getting leaks at the perimeters and it was leaking down into the walls. One of the interesting things about this particular building is that they poured a topping slab on top of the concrete floor. And so that topping slab, when I say topping slab, most people think like, oh, it's a floating floor, or, a float of like a 1/2 inch or a 2 inch of gypcrete. It was like, in some spots, it's 9 inches deep. So we've got the shelf at the edge of the slab where the steel studs come down and they sit on top of the actual structure. And then there's this ledge in behind. So we get water that comes down inside this cavity. And once it gets to the bottom, it can't dry outwards because there's no opportunity for it to dry through that brick. And it can't dry inwards because you've got a concrete shelf there. When we were doing the demo, we actually, as we were knocking through this, these bricks were just crumbling. It was crazy how saturated some of them were. Sorry, I'm not used to talking this much. And that concrete ledge also creates a fairly corrosive environment when it's damp as well. The other thing we found, that what used to be brick ties that were in this area were basically non-existent. And then on the east building, interestingly enough, along the one side, they actually just they did a parch coat of stucco over cedar shakes to match the existing facade. So I've never seen a cementitious material installed over top of stucco, or over top of cedar shakes, but so that was definitely a first. So based on what we had seen on the exterior, we ended up doing all those interior openings to just get a survey of understanding, hey, how much section loss and how prevalent is this issue? Like, do we need to can we wait long enough to get this thing designed properly, or do we need to make an intervention, in an immediate sense? And so when we got into it, the south elevation, which is the one that faces the ocean, was definitely the worst. It was about 25% to, well, sorry, it was about, I think it was 50% of steel studs had, some pretty significant section loss. And then on the east and west elevations, it actually was about 25%. And then on the north elevation, it was about 10. So it was basically, the issues were driven by the exposure to, driving rain from the ocean and from the local microclimate that exists within the bay there.
Look, we have one question here. Were you dealing with a condo association or a management company?
We're dealing directly with the condo association, which for those of you who have done any work with condos, and anybody who is currently lives in a condo and a part of a board, it's one thing to answer to, one person. It's another thing to answer to, it's only 23 in this case. This isn't actually that bad. It's when it's 230 that it's really hard. So, yeah, good question, I guess. And so for our windows and doors, as I mentioned, there's an abandoned steel stud frame within it. And then in some cases, so here's above a sliding glass door. Here's your concrete spandrel beam. All they did was stack a bunch of 2x here, nailed them together, and then fastened this sliding glass door, this flange right to the face of it. not exactly the most structural sound connection that you could make. But it was also fastened at the sides. And it is also, hasn't fallen out yet. So anyway, it all needs to be addressed. The terrace wood deck was interesting. There's actually no insulation in the terrace deck, which is on the east building. Well, let me go back a couple slides. So the east building is this one here. So there's concrete underneath this, and on top of it, there is a wood sleeper system and a plywood deck, and then it extends over. And so we cut a hole in that plywood to look down and see what the condition of the concrete was, and notice that there's actually no air, there's no compartmentalization between the sleepers that support this portion of this occupied area, and then also this this portion of the deck. So basically we've got the opportunity for air to just pass freely from occupied to unoccupied space. And then there are some other areas of the roof that we investigated, and also found that we've got 2 inches of insulation on the roof at best. So needless to say, it was a little bit eye-opening. Sorry.
Luke, one other question here. Question is, the steel studs rusted because of moisture infiltration through stucco and the brick?
Yeah, I think from this diagram here, it probably, there's we have water that was, so let's pretend this is brick. We have water that was able to run penetrate the brick and saturate it, and then there's just no place for that to go. And our vapor drive in New England is primarily outwards, so we've got a large mass here that is then covered with a couple layers of, is covered with a couple layers of elastomeric coating, so it further inhibits the drying potential of that. So we end up with all of this moisture trapped, which then settles to the base of the wall, and at the windows as well. You've got active leaks with bulk water that comes in, and so yeah, basically we've got this wet environment that is unable to dry actively, and it just sits there in the dampness and in the corrosive environment that is wet concrete, and deteriorates over time. So how did this affect our general recommendations? Well, at this point we knew we had to actually do more demolition than we originally had planned. And again, it's a condo association, and there are people who live here year round, and there are people who have spent time decorating it and whatnot. So they don't want to have to change their interior finishes or remove things off their walls, or they really want as little disruption to their living space as possible. So they want us to stay and keep everything on the exterior. So what we had talked about is, originally we had that 2 inches of originally we had the 2 inches of either eaves over top of the existing assembly, and then we said, well, now we got to take out all this brick. So we're taking out all this brick. We have to get back all the way to steel studs, and then the plan is to actually go in and sister in new steel studs, connect them at the top and the bottom to structure to shore up that wall. And then we have all of this leftover space where we used to have bricks. So let's put insulation back. So that's what we decided to do. We're going to put insulation back. And then at the end of the day, we ended up, knowing, being good building scientists, we look at this giant chunk of concrete that frames each one of our exterior insulated assemblies, and say, well, those are huge thermal bridges. Let's try and cut that down. So we added 2 inches here. And so needing to maintain that relationship, we ended up with 6 inches of exterior insulation in the walls with 2 inches over top. And then all of this is supported on a girt system. And then we're using a cement board stucco system to then apply those finishes to emulate what is currently there. So here's here's a breakdown of kind of the enclosure design that we have. So we have a 5/8 exterior or 5/8 gyp, 3.5-inch steel stud that's at 24 inches on center. That was probably going to change actually. We'll probably have to add in a few more. We're actually not going to do any insulation within the wall cavity. We're going to go the ideal wall approach, and so we'll put our air and vapor barrier out here, and then do all exterior insulation since we have the depth that's going to allow us to do that. So 6-inch Cascadia clips, and then a 5/8 inch cement board stucco. Over the concrete, we'll do a similar approach, except we'll only be able to add 2 inches. There's a section of the building that actually has a CMU infill wall. It'll be treated the same as if it was a steel stud wall. On the roofs, we're actually, so the west building roof is a sloped roof. The structure is actually sloped. And so we're going back with an R40 taper or an R40 tapered insulation. And when I say tapered, it's just to account for the areas where it needs to be cricketed to the drains. And then we're using a 2-ply SBS roof to deal with the seagulls, basically. Or at least that's the hope. We thought that, you know, when we had a conversation with the owners and they said, hey, we want something that is low maintenance. That low maintenance option includes a membrane that can't be punctured by a seashell dropping from the sky. And so if one membrane is going to potentially be punctured, let's make it 2. We'll see if that gets VE'd during the construction process, just given the lack of familiarity with 2-ply SBS here in the New England market. Everybody loves EPDM or a single or other single ply membranes, but this is my shameless plug for 2-ply SBS. I think it's great. And so then on the east building, it's actually a wood deck, so similar assembly. And then on the terrace, we're going to actually do the same assembly as well, and then put concrete pavers on top of that. The glazing system selection was actually a really interesting process. Given the location of it, it actually requires us to meet hurricane resistance, so large and small missile impact testing. And so we had originally planned to go with Cascadia as our basis of design from a thermal performance perspective, but we quickly found out that they don't have that testing. And so we were unable to use their windows. And so we went in search of a window that could meet our desires from a performance perspective to, you know, meet the needs of the current climate, but also what the future climate is going to look like at this particular property, given its proximity to the ocean and the, you know, ever increasing severity of storms in the winter. And so we actually came across Wythe Windows out of New Jersey, and I think they presented or were part of the Passive House Massachusetts symposium recently. So their window, we went down that path and had some conversations with them, and we had a conversation with the historic district about, you know, the fact that we're going to be using a UPVC window and trying to emulate, you know, the existing divided lights and how that looks. And they were you know, somewhat amenable to it. But really what ended up happening, so the other window that we looked into that has, you know, the hurricane resistance are, you know, your Andersons, your Marvins, your Pellas. Those ones all kind of have that wood window, but it's clad with either a fiberglass or a metal that allows for it to meet that resistance. And so we brought these options forward to the ownership, and really what the takeaway was is, and the deciding factor, just for everybody's information, Anderson was like twice the cost. Like these A-series windows are like twice the cost of the UPVC windows, and worse performance. But the owners ended up choosing to go with Anderson. The main reason being is there was just some concern with the lack of familiarity with how a Wythe European style tilt turn action operates. It's an older occupant group, but in general, they could not get around the fact that the windows were just not gonna operate in a single or double hung configuration. So that was a loss. That was one of those ones that we were hoping for the best, and at the end of the day, you do what the client wants, and so we're going forward with Anderson. Andrew, do you have anything to add to this part? I know you were pretty heavy into this discussion as well with the ownership group.
Not really, Luke. I think you covered it all. I mean, it was a little bit unfortunate that we went with a lesser performing, more expensive window, but Wythe was able to provide simulated divide lights and maintain the appearance required. I think it's like you said, it's just achieving comfort with the end user. Unfortunately.
Okay. All right. On to what everybody was waiting for. So as part of this, so we never, like I said, we never intended to go down the route of a deep energy retrofit. And then when we got there, and the ownership group was kind of having cold feet about, hey, we're not really sure we want to, this seems like a lot of work. We're not really sure we want to do it all at once. So we pulled together a brief energy saving or a potential energy savings analysis for them based on what their current assemblies are and what our proposed assemblies are. And so, based on the preliminary analysis, this is just a simple UA calculation. On a cold day, occupied year round, the reduction in heat loss to the building could be expected to be between 45 and 65%, which based on we did this in 2020. So that was, 40 cents a square foot of annual savings for year round occupancy. I have no idea what that's like right now with current energy costs or eventual energy costs as we continue down this, the current events. So here's a brief breakdown, just kind of what our energy group did for me. And looking at what we currently have, this is an estimated air leakage loss. I would not be surprised if it was higher than that based on, just some of the things we found as we got further along in the investigation. But you can kind of see here, the reduction, there's quite a drastic reduction in the windows and doors, but then the real one is the exterior walls. Like right now, there's no exterior insulation. We've got 24 inches on center with R13 bat that's wet inside the wall cavities. And so, you look at the D rating from a steel stud on that particular assembly, and then you have uninsulated concrete elements. It's a drastic change. And when we kind of presented this to them, they're like, okay, maybe this isn't the worst thing in the world, but it's still going to cost a lot. Any questions on that? Oh, all right.
Okay, one question there, Luke. You said benchmark air leakage was estimated, was testing not able to be performed?
I would have loved to be able to test it, but what it all comes down to is getting paid to do the work. Like I said, if we would have, and I'll talk a little bit more about this later in the presentation about kind of the lessons learned and where we ended up and where we ended up and knowing what we know now, what we have done differently. And I think, we didn't start out this design process with an idea of saying like, hey, we're gonna do a deep energy retrofit. It just kind of, the fact we had to tear the wall down to the studs provided us this opportunity to add a bunch of insulation where we previously had none. We're getting better windows and we're getting a better roof. And so there's all of those items that if we would have would have kind of taken a step back and said, hey, this building is like at that age when there's a massive amount of renewals that need to happen, let's try and pitch a deep energy retrofit, and let's do some testing and actually get some numbers together so that we can have a data point that we could say down the road, hey, this is where we started, this is where we finished. Now keep in mind, so we're also only under contract right now to complete design. So there is going to be the opportunity for us to maybe do some pre-construction testing, which, you know, now that you mention it, it's definitely something that I would like to, that I'd like to pitch to them and see if we could do, just for a data point and for future conversations and presentations like this. So,
and by
great question.
comparison, you know, we do have projects that start off intentionally pursuing a deep energy retrofit roadmap, where we look at sequencing a combination of you know, carbon reduction measures with different associated rough order magnitude costs, and in that process, we often do the whole building air tightness to establish you know, a benchmark. Again, like Luke was saying, that wasn't the starting point for this project. It was initially an enclosure bit of work, fixing leaks, which is, you know, something architect has also traditionally done a lot of. But yeah, some projects we do specifically include that from the beginning when that is our scope of work.
Mm-hmm. And so, you know, as we started to get into this and recognizing that we're going to this building currently, its current ventilation strategy relies on passive air leakage through, you know, fenestration systems, walls, that sort of thing. We're looking at this and saying, okay, well, we're going to be touching the enclosure, we're going to be making it tighter. It relies on on passive air leakage for ventilation, and now we're going to be greatly reducing that passive air leakage. Are we going to have occupant comfort issues from like, are people going to feel stuffy in their houses or in their units? You know, the general consensus is, hey, we leave our windows open all the time when we're here, but there are those days that it's too hot, and so people you are running their air conditioning, or in the wintertime you're not opening your windows all the time. So, you know, we had some definite reservations, and we identified this as a potential risk that we may end up creating an issue because we've solved one issue. So we recommended completing a mechanical study, or at least something high level, to evaluate how we could potentially introduce controlled ventilation within the building. And as I said earlier, the building is all electric. In the interest of time, I will, and this also is not my area of expertise, I will gloss over this, but if we have any in-depth questions about it, we can definitely come back to it. So so we've got a bunch of heat pumps on the property right now, and the general issue is that there's some of them located in the parking lot, there's some of them located on one roof, on another roof, there's one beside, they're kind of all over the place, and maintaining those particular units and also replacing them is becoming more costly and difficult to manage. So there was some discussion about, hey, can you look at and see what it would cost for us to just replace them all and put them all up on the roof? So we looked at that and we said, okay, hey, here's one option. And then we, you know, left another option as replace as needed. And then we also looked at a third one to do a centralized VRF mechanical system as well. And so we pitched all that to them and gave them some pricing. And at the end of the day, you know, to do anything related to the HVAC or HVAC, including ventilation, which I'll get to next, was just something that proved to be too costly for them to add to the project. And they ultimately decided that they were going to defer that for another, you know, for another phase of their evolution on the building. So ventilation options were continue relying on passive air leakage, which is, you know, essentially engineer speak for do nothing. Then the other option, where there was an existing mechanical chase that was there, or that was in the corridor, that was never actually utilized. And so that was an opportunity for us to potentially pressurize that corridor and provide fresh air via that via that mechanism. And then on the east building, we would still have to either rely on passive air leakage or go the route of introducing either distributed ventilation systems and heat recovery into those units. And so that was kind of the third option, was to say, hey, let's try and add an ERV to each unit. Most of the heat pumps, it's all forced air, that's all electric resistance heated, or it's cooled as well. And so there was the opportunity that most of those were actually on the exterior walls. So potentially adding an ERV at that exterior wall, there was kind of that opportunity there that could have been potentially a low cost solution. So lessons learned. So working with an existing building is full of surprises. So you got to approach these projects and be really flexible, and kind of recognize that it's not going to go according to plan, but also look for opportunities for you to, you know, I think I don't know how many years ago, I was at a presentation with Passive House New England. I think Tim McDonald was there and giving a presentation about leverage, and, you know, finding those leverage points for you as a passive house enthusiast to kind of further your agenda. And so with an existing building, approach it with that opportunity and look at areas, you know, things that are deteriorated and ready for replacement. You know, try and push that agenda and try and give people the long-term plan, like and recognize that it's a long-term play. We're not going to be able to do everything all at once. So you just got to be flexible and try to incrementally improve our buildings. Window system selection was limited by performance. And ultimately it was selected for just familiarity. Start a mechanical study specifically related to ventilation in terms of a deep energy retrofit at the beginning of a project, or even earlier. You know, when we were engaged in this condition assessment, we were working for the structural engineer, and now we're the prime on this particular project. In hindsight, and something that we, you know, have learned from this project, is we need to start having that mechanical discussion, you know, right from the get-go. When somebody says, hey, can you come look at our enclosure, we'll say, hey, can we look at the mechanical too? The Historic District Commission is something that is it was also a constraint, but it really kind of handcuffs you and limits your ability to change the appearance. You know, like if you wanted to go to the energy sprung approach and put a sweater on your building, you know, that may not necessarily fly with the Historic District Commission. And then the final one is costs. I didn't really touch too much on this, but basically it's a 23 unit building. And if we were to do the electric or the mechanical upgrades, that the total price tag's $5 million. It's just over $4 million without the mechanical work. So, I mean, you're looking at a considerable cost, $200,000 per unit. You know, how do you pay for that? Most of the time it's a special assessment. There are people who are looking to sell their condos because they can't afford to stay there with that cost. And you know, it raises those questions about equity, you know, for high performance buildings. And then the other thing is, you know, what's out there from Mass Save, and I know Luke's on the call, so I'm not gonna you know, throw stones or anything like that. But you know, right now I don't know if there is, and based on research that we did, it doesn't appear that there's an opportunity for us to submit a project like this in much of a capacity or a formal capacity, and what opportunity there would be to have this type of work incentivized. So the main takeaway for us is that, you know, we have a climate crisis, and we need to retrofit a lot of buildings in Massachusetts. It's something like what 85% of the 2050 building stock has already been built. So, you know, we got to put our work boots on. We got to get to work. It's going to be expensive, and we need further government and utility incentives to help push these projects across the finish line. Either that, or we need to do a better job of taking looking at a longer horizon for how we're engaging with an ownership group about their building and saying, all right, let's look at a 30-year plan. You have to replace your roof at this period of time. Let's improve it X amount above energy code. Then you've got your windows in another couple of years. Like, let's phase this all together so that we can get you a path or a plan to get you closer to net zero or passive house, rather than trying to eat the whale in one bite. So that's it. And then I'll leave this slide up here as again, RDH is one of RDH's things is our core values that we really take pride in is always learn. So we've got our technical library available with a bunch of different resources and guidelines. Some of them are related to passive house, others are just related to practical things like cladding attachment, how to account for super insulated buildings, how to take 12 inches of mineral wool and attach some cladding to the outside of it, that sort of thing. And then we also have our Learn Building Science website that we have a lot of live events that we offer. If you're familiar with John Straub, he's often presenting, and we run that out of our Waterloo lab. So there's usually something related to building science. I think we do it for like 6 months of the year. We do 6 presentations, and we recommend that, or invite everybody to come join. Most of them are held virtually, and they usually are pretty well attended. So with that, I'll open it up for more questions. All right.
So one comment here, Luke, from Hank, the phased approach makes perfect sense. When might the occupants put in ventilation as a priority?
That's a good question. We still, and it's an open one as well. We had a conversation with the owners about giving people the option to opt in if they wanted to add ventilation as part of this project. But ultimately they said, you know what, we just want to do the enclosure and just do, this scope of work. So I'm hopeful that I'm hopeful that they don't end up with a ventilation issue, but the ideal time would be now, when we're doing this project, to be able to coordinate penetrations through the enclosure, that sort of thing. That's the ideal time. But I would anticipate that doing it after the fact would also not be too difficult, other than I hope they don't have to cut into my brand new roof. Hank, your hand's still up?
Yeah, can you hear me?
Yes,
No.
I can.
Oh, great. So where did you end up with them in terms of the heat pump? First of all, I was surprised to hear that all of this all-electric building was a mishmash of different brands of heat pumps. So individual condo units had been doing their own thing, I guess. Where did you end up with the idea of standardizing or doing something more central?
Again, again, we made the recommendation and we did a cost benefit analysis for them. And ultimately they ended up saying, we just want to do the enclosure. We'll focus on the mechanical down the road. but yeah, each individual unit owner, no, actually, sorry, the condo association there is responsible for heating and cooling. And they have a relationship with a local vendor, and essentially when one compressor unit kicks the bucket, they basically call them and whatever's the cheapest, they install it. And it's just,
Wow.
yeah, I think when we did the survey, the mechanical survey, I think there were 7 different manufacturers. And I didn't even know there were 7 manufacturers of heat pumps. So I mean, it was pretty crazy. So yeah.
Wow.
I see.
And what's the hot water situation?
That's something that we didn't explore. That was kind of outside of our scope. And I think I think, yeah, they have no natural gas there, so I think it's gotta be electric resistance, I would imagine.
Well, this is a terrific example of just how difficult it is to do deep energy retrofits on existing buildings. This is an incredible, an incredible story with a building that's going from, precast not precast, but cast in place concrete with, heat transfer that's beyond your imagination, to having to make this really work. So amazing work. Thank you.
Thanks, Hank. John, I see your comment about $2,000 or 200K for mechanical per unit. That's 2,000. That's 200. That's 200K per unit without the mechanical work.
Yeah, that's just for the envelope work.
That's for the windows and the roof and whatnot.
Yeah.
Anybody else? I saw Luke chimed in.
Happy to talk to that point.
Yeah, and yeah, Luke, I was trying my best not to, I don't want to throw
Understood.
anybody under the bus. I know you guys are busy over there. So
Well, I do just want to say, so the residential new construction program and the passive house program certainly support energy efficiency improvements, retrofits that are, and the technical qualification is, I don't have the language right in front of me, but technically, if it's more than 50% beyond the cost of the assessed property value, it should be able to meet the new construction requirements, and therefore be eligible for the new construction high-rise incentives. Those are certainly not going to get you to $200,000 per unit.
yeah, I'm not suggesting that utilities pay for the whole thing,
but that said, also the local utilities are always interested in working with projects that are pushing the envelope, so to speak, and may
Great
be
pun.
able to assist in addition. So it is, the first step is registering the project and then finding our path to the best incentive available.
Okay, well, that's great advice. Yeah, we're like I said, we're still in the process of finalizing the design, but yeah, I think there was the plan to, as we start going through various approvals, with the historic district and conservation, well, we would be reaching out to the local
It
utilities.
is also worth it to register early, because the utility may come in with some suggestions and offerings that will impact decision-making, for instance, regarding mechanical systems or other. They may have some guidance and offering that will assist in those decisions.
Okay, thanks for that.
Sure.
I have a question for you guys. First off, this is an excellent presentation. So thank you so much for taking the time to do this. And I know this is obviously a long process here. You're in the early stages. So thank you for presenting, and we hope to see some more from you when it's in construction here, or when you're doing the work. So you talked a lot about, having convinced the clients here of some of these benefits. You obviously got them on the building envelope, and they saw a lot of benefits there that push ventilation down the road. So I'm just kind of curious if there were discussions with them of some of the other benefits. They obviously they prioritize occupant comfort. Did you talk with them about things related to maybe indoor air quality or sort of humidity, things that ventilation systems could deal with? And were those, impacts in their decision making?
Yeah, I think if we would have spent more time on the table that we have, we, laid out those arguments in terms of, I don't know if we necessarily, we did talk about elements of indoor air quality. I don't think we actually called it out specifically, like talking about smells between units and that sort of thing. But we talked about, reduces issue with air quality, smell transfer, condensation issues, mold. So I mean, we did talk to them about the impacts that it does have. At the end of the day, it was running. They were out of the bandwidth to climb that last hill, and it's. I mean, sitting on it from the professional side, you look at it and you're like, come on, we're almost there. And then like, if I lived in that condo, which I will never live in a condo because, I've spent enough time working on condos. If that was me and somebody came to me and said, hey, I need you to spend $220,000 on your house to fix it, I'd be like, all right, when do I sell?
Right.
But I think, the other flip side of it, right, is trying to come at it from a property value perspective and what it's going to do for their property value. And the other things we started to try and have the conversation with them is that, like, these decisions that we're trying to make on your behalf, we're not talking about like trying to deal with, resisting the current elements in the climate that you currently live in. We're trying to talk about like the climate 20 years from now. Maybe you did come out to the Cape for Thanksgiving this year, and then we had a nor'easter come through and you lost power, or maybe it was a major event, you couldn't go anywhere. You're not going to freeze to death when the power goes out in this building right now, or like right now you will. You're going to freeze to death. But like, when we get to a point where we have a 60% improvement on the thermal performance of your building, you're going to be able to stay in there a little bit longer and be a little bit more comfortable. And so we started to have those conversations with them about, being able to shelter in place for a period of time and like trying to provide that opportunity for them, especially given the vulnerable position that the building is in.
Just for 1 second, it sounded like I'm very familiar with doing work on the Cape, and in this particular building, it sounded like a lot of people were summer only. And so when they all take off, I mean, a lot of those smells go away in the summer when everybody opens up their windows. And then when they're all done, they close them up, turn everything down, and boogie to Florida. And that's what it sounds like a lot of those places are. So they keep it minimalist, and they're really not there in the winter. So it's a tough uphill sled for selling energy efficiency to a building like that. And
Thanks,
they're not,
John.
and it's not like they're affordable housing. So where you could get a lot more help probably doing it, because it's waterfront and it's special.
That's an interesting question. I'm curious. So it's not affordable housing. What is the average resale value of one of these units right now to compare it to the $200,000 investment?
I think recently there was one of the studio units went for like 600 or 650, and studio unit, I mean, or there's no bedroom in it, and it has a kitchen, and I think it was like maybe 500 square feet.
Yeah, they're all $1 million plus units for sure with that water view.
Right.
Yeah,
Downtown.
and you know, turn it like the flip side, like let's look at it 4 years from now when this project's finished. You know, if you had full new mechanical centralized VRF system, you know, ventilation, the whole 9 yards, and a high performance enclosure, like right now, does the real estate market value that? Like how much do they value that? But I think as we move further and move further down the climate change pathway, I think that there will be more value placed on that. So there is some property value to gain, and like the building's going to look nice as well, and it's going to be, hey, we did all this work on the building. There's going to be some incentive for, yeah, and I imagine property values will increase.
As long
Yeah,
as
and
it
you
doesn't
guys
fall
should
down
be,
first.
Fair, John, fair.
That one in Florida that just tanked and fell down was horrific, but you know, when it's not maintained, and it looks like in your exploration, you unearthed a lot of different structural deficiencies that, you know, they're dangerous. And
Yeah, I mean, like I said, we're working with a structural engineer on the project, and they did look at the concrete superstructure, and the concrete superstructure is sound. Like this thing is built like a fortress. It's, you know, it's all post and beam. There's not a large span between columns. It's very well constructed, so there's not a concern from that perspective. But yeah, like some of the buildings, especially with you know, with coastal flooding and tide inundation in Florida, it's definitely something that is super. It's, you know, we've done
salt air.
Yeah.
Salt air is just brutal.
We've done some investigation work down in Florida on newer condos, and actually worked on a project that I think was five buildings down from the one that collapsed. And you know, Florida is just a different. It's just a different climate to operate in, and the you know, the vapor drive's different. There's a lot of different considerations. They get, you know, get hurricanes all the time. It's I don't know why you
You
want
don't
to
get
build a
the
new building
freeze
in
thaw
Florida.
though. That's one thing that up here.
Yeah.
You get freeze thaw.
I-
When you start taking water in those assemblies and they start ponding and doing all those things, it just freezes up.
You
It
sound
pushes.
like me. You sound like me when I talk to my West Coast, the West Coast offices. They're all in temperate climates. Nobody deals with freeze thaw. I'm just like, yeah, until it freezes, and then they're like, what?
it seems to me as if there should be an opportunity for you to take some version of this presentation. You don't want to show everything you showed us, which I'm so glad you did, but to put that together for the use of the condo association, for everybody's use, because it should help them actually increase the property values. This is the thoughtful process we went through. This is what we did. Not to say they couldn't do more, but I think we should try to leverage everything we can in terms of this type of thoughtful building science approach to rehab.
Yeah, that's good. Yeah, it's a great point, Hank.
You just got to be careful because your taxes go up too. A lot of these people are fixed income or retired.
I see somebody asked if we do. Maria asked if we do tension cable buildings in Florida. Not currently. I'm Canadian. I actually don't work below the Mason-Dixon line because it's too hot. So there might be other people within my office who'd be willing to travel that far south, but for me, I'll melt. But yes, we do work in Florida, all joking aside. We're not primarily a structural firm. We mainly work on the enclosure portion of it. And then we do have a structural department that does facade design, but yes. Tension
How many of
capability.
these units actually have air conditioning since they're seasonal?
All of them. All of them have it, with and there are 2 units that actually still have through wall shaker units in their building, or in their unit, and those ones don't have forced air. Those ones are electrical resistance baseboards.
So otherwise, they've got heat pumps doing AC and heating.
Yes.
Okay. Interesting.
And some pretty old heat pumps at that, or some of them are pretty old.
Yeah. All right, well, thank you. I think it was a great presentation of a very challenging project. This is the kind of stuff that's going to be haunting us for the next 2 decades. So thank you for being a pioneer.
Anytime, Hank. You can see I've lost a lot more hair because of this one. All right, everybody.
Thank you, Luke. Thank you, Andrew. This was a great presentation.
Yeah, and if anybody has any questions about the project or wants to learn more, again, our emails are here, or you can just look us up through the website, that sort of thing, or just ask Andrew.
All right.
Well, excellent. Thank you guys so much. We look forward to hearing more about this project in the future. And everyone out there for attending today, thank you for being here. And check out our website, phmass.org, and do that /policy to get info on all the code stuff I was talking about at the beginning of the session. And please weigh in. So thank you guys so much. See you later. Stay safe.